today we are going to learn about flash distillation. Here the course outcome of this equipment is you will come to know the pharmaceutical industrial application of this distillation equipment. Okay, in this equipment we are mainly going to study about the principle, construction, working, use, advantages and disadvantages of this equipment. Initially, I'll tell you the principle behind this equipment. Here we are transferring a liquid mixture from a higher pressure zone to a low pressure zone. During that transition, the liquid mixture will suddenly flashes or sudden vaporization of that liquid mixture will occur. Okay, during that sudden vaporization or sudden flashing of that liquid mixture, the liquid will form as vapors. Okay, from that vapors we can separate the molecules. Okay, that is the main principle behind this equipment. Okay, the flash distillation is also termed as equilibrium distillation. Why flash distillation is also termed as equilibrium distillation? Because during transition from a higher pressure zone to low pressure zone, the vapors will exhibit or vapors will store in another chamber. From that chamber, the separation is only applicable when the vapor is attained equilibrium. Then only we can separate that vapor molecules into different liquids, okay, different separate equipments or different mixtures. Okay, so that is why it is also called as equilibrium distillation. Okay, so process in which entire liquid mixture suddenly vaporizes by passing feed from high pressure zone to low pressure zone. That is the main basic principle behind what? Flash distillation. Okay, also known as equilibrium distillation, since separation takes place when liquid and vapor are in equilibrium. Only when that liquid is in equilibrium, then only we can separate that vapor. That is why it is termed as equilibrium distillation. Okay, I will show you the equipment. This is the flash distillation equipment. I have already told the principal section. Now we are moving on to the construction portion. Okay, in the construction of flash distillation equipment we have several parts. The main part of the flash distillation equipment is the pressure reducing valve. Okay, we have a heating chamber in this equipment, and we have a pump over here, then feed reservoir, then there is a heater in the chamber, and we have a liquid vapor separator also. Okay, this is the total parts of an flash distillation equipment, and this liquid vapor chamber we have a liquid opening over here and a vapor opening over the top of the equipment. So this many parts are contained in this flash distillation equipment. Moving on to the working of this equipment. Okay, as you can see here, the feed reservoir is connected to the pump. Okay, how pump will helps to pushes the feed into the chamber. Okay, in this chamber we have connected one heater over here. How heater will heat the feed that is introduced through this opening, and heater will heat the feed and it will transfer to the pipe that we have arranged over here. Through this pipe, the high pressure zone liquid will travel to the low pressure zone. Okay, how this transition occurs? Here we have a pressure reducing valve. This pressure reducing valve will reduce the high pressure zoned liquid into low pressure zoned vapors. Okay, after passing through this pressure reducing valve, the liquid will flashes or suddenly vaporizes into vapor molecules. Once these vapor molecules reach in the liquid vapor chamber, these vapor molecules will attain an equilibrium. After attaining equilibrium, these vapor molecules that is having higher boiling fraction, the molecule will settle as liquid over here, and the molecule that is having low boiling fraction remain as vapor over here. Okay, then we can separate the molecule that is having higher boiling fraction as liquid from the bottom of this chamber. Okay, and the molecule that is having low boiling fraction, the vapor we can separate from the top. Again that vapor we can condense and take the low boiling fraction liquid. Okay, that is how we will separate a molecule in a flash distillation equipment. Understood? One more time I'll recollect this one. Initially we will introduce feed through this inlet, and we have a heater over here. The heater will pump the liquid through the pipe, and this is a higher pressure zone. From this higher pressure zone, the pressure reducing valve will reduce the pressure of this liquid, and sudden flashing of liquid occurs, sudden vaporization of liquid occurs, and the vapor will contain high boiling fraction and low boiling fraction liquids. Okay, the vapor higher boiling fraction and low boiling fraction vapors. From that vapor, when that vapor attaining equilibrium, the molecules having higher boiling fraction settle as liquids, and the molecules having low boiling fractions remain as vapors. And during this sudden pressure reduction, there is a cooling sensation in this chamber. That is why the molecules having higher boiling fraction is cooled down and or condensed to form liquids. Otherwise, it will remain as vapor only. Okay. Then we will remove the vapor and liquid separately. Okay. And then we can separate both the components. Okay, then moving on to the uses. Mainly we are using this flash distillation equipment in petroleum industries. Okay, for refining crude oils, we are most commonly using flash distillation equipment. So separating components which boil at widely different temperature, also we can use flash distillation, and used in petroleum industry for refining crude oils. And what are the advantages? It is a continuous process used for obtaining multi-component systems of narrow boiling range in oil refinery. That is, if a liquid mixture is having mixtures that is having narrow ranges of temperature, we can separate using flash distillation. Okay, then disadvantages are not effective in separating components of comparable volatility and not suitable for two component system. That is the disadvantages of flash distillation equipment. Clear the concept? Okay, so by studying this flash distillation, you will come to know how this equipment is applicable in an industrial way. Okay, how we are in pharmaceutical industry, how we are using this kind of distillation equipments. Okay.